These are the first 5 problems for Algebra A's Test 5 for Quarter 2. And the first 2 problems are going to be similar. They're going to ask us just to graph the inequality. The difference is the type of inequalities or the way they're written. And so if we look at the first one here, we are given it in slope-intercept form. Notice that the y-intercept is right here for us. That's what I want you to start with. Graph that y-intercept. And so we go down one space on the y-axis and put the dot. And now we use the slope. So the slope is 1 to 2. So that tells us we're going to end up going up 1 and then to the right 2 spaces. And so we can do that a few times. Up 1, right 2, up 1, right 2. Now, when we run out of room that way, we can also go the other way, which is the opposite of both of these. So that would be down 1, 2 to the left. And what that does for us, it gives us a bunch of points to be able to draw a line. Now we have to worry about the type of line that we're going to use. So whenever we see that line underneath, remember that means that we are having the solutions on the line along with either above or below the line. So we use a solid line to represent that the points on the line are solutions to this inequality. That means we get values that actually work when we plug the numbers in to the inequality. They will equal each other. But the values of y are also greater than. Notice that y, positive y, is greater. So what that means is any point on the line, the y values equal, which are solutions, but anything greater than that point also is a solution. So greater values for y are above the line. And so that's why we end up shading above the line to represent all the solutions. Well, the next problem is a good one for using x and y intercepts. Now you can choose to solve for y and get the same answer, but x-y intercepts work pretty well as well. So take that 3x, set it less than 12, and do the negative 2y is less than 12. And solve for both intercepts. And the way we do that is just divide by 3 on the left-hand side here, and divide by negative 2 on the right-hand side. And so we get 2 equations, or 2 inequalities. X is less than 4, so what we do is we go over here at 4 on the x-axis and put a dot, and y is now not less, but greater than negative 6. So remember, when you divide by the negative, that inequality sign needs to switch directions. We still go down to negative 6 because we need to define the line. And the line is defined by these 2 points and the line that we can draw in between. Now, since it does not have that line underneath, we use a dashed line to represent that the points on the line are not solutions. But solutions can be found on one side of the line or the other. So let's see how we can do that. Well, we could either use the x value here. The x values have to be less than 4. So any point on this line means that the x values have to be less than that number. So that means we're going to end up shading towards the left. And if you wanted to use the y values have to be greater than negative 6. So if you're on negative 6 here on the y-axis, the y values have to be greater than that number. So either way, it tells you that we're going to shade on this side of that line. Well, the next 2 problems ask us to solve a system of inequalities. So now we've got to graph 2 lines. So we've got a choice here for this problem. We could either use xy intercepts or we could use the slope-intercept form. So if we're to use the slope-intercept form, we need to move this negative 2x to the other side. So I'm going to go ahead and do that. I'm going to add 2x to both sides. Add 2x over here, and my new inequality looks like this. Y is now greater than or equal to 2x minus 1. And you see, then you can use the slope-intercept form. So negative 1 is the y-intercept, 2 is the slope. So remember, this is the same thing as 2 over 1. So that tells us that we're going up 2 over 1 to the right. Up 2 over 1 to the right. We could also go the other direction, down 2, left 1. Gets us on that same line. Now, there's a line underneath, so we're using that solid line to represent the points on the line are solutions. But we have a direction to shade, either above or below the line. So let's take a look at the inequality sign. Y is greater than the y value. So any y value is actually greater than that as well. So we're going to end up shading above this line. So just draw some arrows above the line. So this is the side that we would shade, but we first want to find out what the other line looks like. So this is a good one for xy intercepts again. We could solve for y, but there's a little more work to do. So I think xy intercepts might go quicker. So let's just take the 2x is less than 10. Negative 5y is less than 10. And then solve. So x is going to be less than 5. So we can plot that point over 5 on the x-axis. And if we divide by the negative 5, remember there's a couple things happen. First of all, it's going to be a negative 2, but y is now going to be greater than because we're dividing by that negative 5. So go down 2 spaces, put the dot there, and draw the line. So no line underneath, so it's a dashed line. So I just draw a line between those points. Dash line. Now we figure out the shading. So again, we can either use the x or the y. So the values of x have to be less than whatever number we're on. So if I'm on 5, the values of x that are less are in this direction. Or I could use this one here, y at negative 2. So y is greater than negative 2. So that means above the line. So any point needs to make sure that we shade on this side of that red line. So we need to shade above the red line, but also above the blue line. So the area that works for both is in this region up here. But again, it needs to make sure we stay above the red and above the blue as well. We've got one more line, or one more system of inequalities, and it's good for slope-intercept for both. So we're going to use that y-intercept here, negative 4, and then use the slope. It's a 1-to-1 slope. If you don't see a number out in front of the x, it's just 1-to-1. So it goes up and to the right each time. And we can also go the other way, down to the left, and we draw the line. Now, no line underneath, so it's a dashed line. And then we can also figure out the shading. Y needs to be greater than. So the values of y are greater. So greater means you're going to end up shading towards the bigger y's, which are above the line. We move on to the next line, and it has a y-intercept of 1. So we're going to go up 1 space, then use the slope. Negative 1 to 2, so that means down 1, 2 to the right. Down 1, 2 to the right. Down 1, 2 to the right. We could also go up and then to the left, gets us on that same line as well. And we can go ahead and draw the line. It's a solid line because it has the line underneath the inequality sign. So that means that the values of y are going to end up equaling this expression. And when we look at the inequality, though, it says y has to be less than as well. Less means smaller, so the y values are smaller than any point on the line as well. And so that means we're going to shade below. So we look for the region that works with both. We need to be above the blue, below the red. So the only region is right in here. Well, one more problem, and this one involves determining whether a point is on the line or lies on the line defined by this equation. So what you're going to do is take the x value, which is 6, and you're going to put that in place of x in the equation. And take the y value, which is 18, and that goes in place of y. Now, the common mistake is if I had the y term right here, this 1/3 y over here, and the x term over here, sometimes people think, oh, 6 is x, so I need to put that in there first. And so when we go ahead and do that, what we have now is 2/3 multiplied by 6. Now again, make sure you put the right number in place of the right variable. 6 is x, so 6 has to go in place of this x. So I'm going to treat 6 as a fraction. Write that as 6 over 1 so you can see the cross-canceling that occurs. Same thing with the y term. We've got a fraction here, so treat this as 18 over 1, and then minus 2. So now we can go ahead and do some work. We can cross-cancel. 3 goes into 6 2 times. This 3 goes into 18 6 times. Now let's multiply across. The 2 and 2 end up multiplying to make 4. Here, 1 and 6 make 6. Make sure you bring down this negative 2 and then finish off the problem. So we're left with 4 equals 4. When the numbers agree and they are equal, that means yes, the point is on the line. So on the test, though, you're going to have to show me that substitution and show me how the numbers equal, and then either say yes or no, depending on whether the numbers are equal or not. Well, part 2 will have the last 4 problems.